Hello and welcome to 3.2 Segment Measure. Before we get started, I just want to talk about the word measure. Okay, it's developed slowly over time, which means when it first started, it was really imprecise. So, like, I don't know if you've ever heard of people measuring things in the length of a king's forearm. Actually, the measurement of a foot started with someone's foot. And same with the measurement of a meter. I believe it was like 2 marks on a rock, and people would make sticks that were exactly between those 2 marks on a rock. So it's gotten much more precise as civilization has become more advanced. Okay, so the first postulate for today is called the ruler postulate. Every point of a line can be placed in correspondence with a real number. So the main idea here is that if we have a segment, we can put a ruler up to it and we can know exactly how long it is with a number. And the coordinate of the point on the line is the number that corresponds to that point. And this is just a number line. You have graphed on a number line before when we've done inequalities, and so here we can say C is at -2.5, B is at -1, and A is at 3. So they correspond to those numbers on the number line. Distance is between 2 points, and it's the absolute value of their difference in their coordinates. So remember we've talked about last year in Algebra 1 that distance is always positive. No matter what, you cannot go a negative distance. So if I take the first point and I subtract the second point, even if that second point's a negative number, I'm going to be adding, right? Because subtracting a negative is the same as adding. We will know the distance between those 2 coordinates. So let's practice that. I want you to push pause on the video and I want you to get 3 answers. The distance between B and D, or the length of BD. Okay, the distance between A and E, or the length of AE, and so on. Okay, so do those 3 and then see if you're right. Okay, so here's me showing my work for how I found the distance of BD, the segment BD, or the distance between point B and point D. So point B is at -5, D is at 2, and when I subtract the 2 I get a -7, and if I take the absolute value I get +7. Likewise for AE and CE. Okay, so we have a definition of betweenness already, and this is a new and improved definition for betweenness. Okay, in chapter 2 we talked about just a point being between 2 other points, given that we could add them together, but here we actually can have measurements, right? So B is between A and C if the ray BC intersects the ray BA at point B. That was our original definition. So, and they had to be collinear, and we wrote it like this, the ABC with hyphens. But now we have a point M in the middle, and if we measure A to M and we add that to M to B, then we would have the length of AB, which would mean that M is in between, or between A and B. So it's, like I said, a new and improved definition when we can use measurement. Okay, our last postulate for this section is called the completeness postulate, and it just means that given a ray and any positive real number R, there's exactly 1 point on the ray that will equal R. So if I say R is 7, I say the ray is infinitely goes in one direction, it goes in the direction of B, If I start and lay my ruler on the beginning of the ray, which is point A, and I say there's a point 7, I measure out 7 units, right there would be point C. Okay, so let's talk about the difference between the ruler postulate and the completeness postulate for a second. Okay, they're both on segment measure, but the difference is the ruler postulate lets you measure segments with a ruler. Okay, the completeness postulate lets you make segments of given lengths. So, in other words, a ruler postulate starts with segments and finds their lengths. The completeness postulate reverses that. Okay, so it's important to know the difference. They are not the same postulate and they don't mean the same thing, but they are easily confused, so you need to know which one is which. And last is your WSQ Summary. Okay, you have 5 practice problems. Just to kind of go over number 1 and number 2, when I say graph the square root of the number, you're going to make a number line and you're going to estimate where it goes, because like the square root of 12 and the square root of 17 are not perfect squares, so you're going to have to discover which integers they go between and then plot a point, okay, to the best of your ability. Now within tenths, okay, I do want it within tenths, so if you pick 2.1 and it's really supposed to be 2.5, you got it wrong. Okay, so be precise, and I will see you in class.